So, here's a quick problem for you. And this is a perfect illustration of mentally assisted versus paper assisted versus calculator assisted. Now, because you've got a calculator there on your desk, you may be tempted to go straight to the calculator with this, okay? And eventually we will punch this into our calculator to verify that we're right. Do you guys remember? Think back to the first lesson, right? The answer's not important to me. I mean, the answer's useful, but it's about how we get there. That's what this is about, okay? So I know we have this, particularly from primary school, we have this urge to jump to the answer, Don't do that. It's not the most important part. It's how you get there that matters. Okay? So, let's have a go at this. The first strategy I'm going to teach you, strategy A, is estimation or rounding. Okay? Now, you learned this last year. Here's what I'm going to do. Okay? I'm going to take that line, 15 plus 37 plus 18 and so on, right? And I'm going to use my knowledge of approximation. We learned how to approximate things in significant figures last year, so let me jog your memory again. Why is it useful? Instead of saying equals, I'm going to say this is approximately equals. Okay, so it's a wiggly equal sign, right? So what I'm going to have on the right-hand side will not be exactly equal to what I have on the left, but it'll be close, and in real life, often that's all we need, right? We just need it to be pretty close, okay? I'll give you an example. You guys learned about pi last year when you did circles?
No.
No?
9.
Okay, alright. You will learn about pi. It's this long number here. It's one of those crazy irrational numbers that we were talking about before. Now, your calculator, no, it's not a cert, but it is irrational. All of these decimal places, they go off forever. And you might think, wow, if I want to be accurate and precise, I'll need a whole bunch, right? Well, even civil engineers who have to build buildings that need to stand up, they only use that much of the number. A tiny proportion of the whole thing, but it's enough, okay? And that's what I'm going to do here. I'm going to approximate these numbers one by one, and I'm going to see what I get. So, 15. If I round that off to one significant figure, because it's got 2 at the moment, the 1 and the 5, what would it be to one significant figure?
20.
It'll be 20. That's exactly right, because I want this to be 0, and 5 is, well, 5's that funny case. It goes up, doesn't it? Okay? So I round that off to 20. 37, if I want one significant figure, it's going to go up to 40. I'm going to keep going. 18 is going to go up to 20. Now I'm going to pause. Remember, I'm trying to estimate this, right? Now, normally I'd say the 45 should go up to 50, right? But hold on. I made this one go up. So wouldn't it be helpful for me, because I'm just estimating, just rounding. Wouldn't it be helpful for this to actually go down? Because then they'll kind of balance each other out. Does that make sense? So I'm going to write that one as 40. And then you got 22 on the end. And that's going to be 20. Okay, now, have a look at this. This is 10 times easier to do than this, right? All of the zeros don't really matter, right? Because if I go 2 plus 4 is 6, plus 2 is 8, plus 4 is 12, plus another 2 is 14, and then I put all of the zeros on the end. Okay. 140. Now that's not exactly right, but it is very close, and often close enough is all I need. Okay? And that was strategy 1. Let's go strategy 2 and get something precise without your calculators. Okay? Do you remember last year we learned something called the commutative law? It does sound a little bit like communism, which is not a coincidence, by the way. Okay? Now, the commutative law is very simple. It means that some operations, it doesn't matter what order you do them in. You can do them front to back or back to front, and it's all the same. Okay? Now, there are 2 operations we know about that are commutative, where you can change the order. What are the 2 operations? Yep. Multiplication and addition, right? 3 times 5 is the same as 5 times 3. They're both 15. And adding, I can change the order here to help me. Okay, so watch. And I'm going to ask you guys to put your laptop heads down. I didn't ask before because I was just waiting to see how self-disciplined you were. But I have waited and I've made my judgment. Well done, Daniel. Okay. Shh. Have a look at this with me. See this here? Okay, I'm going to write it out again. but I'm going to reorder it in a way that makes it easy for me, okay? Because some orders are easier than others. I'll give you an example. Have a look at these two. See these guys? If I pair these two together, because there's a 5 and a 5 there, right? My daughter who's in year 1 would call these friends of 10, right? 5 and 5, they're going to add up to 10, right? So I'm going to say equals, this is going to be exact, right? I'm going to put the 15 and the 45 together. I don't have to put the brackets, but it makes it obvious to me what I'm combining. I've got those two. Can someone else tell me what's another thing I should pair up? Yeah.
22 and 18.
Fantastic. There's the 2 and an 8, which are friends of 10, right? So if I combine these guys, that's also going to be easy. One last number that's left over. Okay? Alright, help me out. 15 plus 45. 60. 18 plus 22. 40. And that's a 37 on the end. Now that's easy as well. That's 100. 137 exact. No calculators required. Okay?